Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap. I'm very excited about this one. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, you will have the opportunity to access the webinar later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll try to get to as many as we can near the end of today's webinar. We also have a couple polling questions during today's presentation. Get everybody engaged with. And finally, at the end of today's webinar, we And before we get started, we do have a polling question I do want to go ahead and push out to the audience, and then we'll go ahead and get started with your presentation. All right, guys, here's the first of the two polls that we are going to push out to you today, asking your familiarity with chaos engineering. You can choose from I run experiments frequently at my org, I run my first experiment, I have heard about chaos engineering, or this is my first time hearing about chaos engineering. So go ahead and make your choice, and I'll give the audience about 20-25 seconds more to go ahead and make your selection. Then we'll go ahead and close out the poll, and I'll turn the reins over to Anna for her presentation. So, but just a real quick reminder, during today's presentation, if you have a question for Anna at any time, you don't have to wait until we get to the question and answer period. You can go ahead and use the GoToWebinar control panel and submit your question. And then, like I said before, we'll get to as many as we can near the question and answer period. Okay, let's go ahead and close out today's poll, and we will take a look at the results. All right, looks like the majority of folks have heard about chaos engineering. But beyond that, not much has really been happening in that space. So Anna, hopefully that kind of gives you a little level set to go with. And I'll put myself on mute, take myself off camera, and let you get right into your presentation.
Thank you very much for that warm introduction. My name is Ana Margarita Medina. I am super excited to be here on today on this DevOps.com webinar, but I also want to thank all these listeners to tuning in today. I know the world is just a lot's going on, so I really appreciate that y'all are taking some time to learn something new. As we launched this poll, it's actually really interesting to hear that a lot of you have heard about chaos engineering and only a few of you have actually run an experiment. Today, it won't be so much about talking about different types of experiments that you can do in your organization. We're gonna cover a little bit more of that culture. We're gonna talk a little bit more about going beyond that and how is it that we can benefit from such a chaotic industry, a little bit of a category, and continue learning from that. So just to touch base on it, today we'll be talking about how is it that you can make these little pages go down a little bit less, but also make a culture where that message or those things happen less, but every single time that you do have one of these pages or incidents, you're always learning from them. That is one of the beauties from chaos engineering. You're breaking things on purpose in order to learn, understand those breaking points, and make your applications better. To set the tone for today, I wanted to touch base a little bit about those fundamentals of chaos engineering, and we're just gonna kick it off. To set the tone, I think one of the things that 2020 taught us was that we are relying on a lot of things that are going to fail. We're not 100% confident in how our systems are going to scale really well, how we can do everything remotely. But when it comes to distributed systems and software being built today, it's a tough fact to face, but as we know it, software is going to break. We need to rely on these technologies, but how is it that we can continue innovating and delivering products in a ways that we're not putting failure at risk, that we're still thinking of those customer-centric things? And the reason for it is that downtime is really expensive, but we also need to be constantly customer obsessed and make sure that we are delivering the best experience for them. For those that are getting started in chaos engineering, or this is your first time hearing about it, I want to touch base on, we know that things are going to fail. We know that some of these failures might be extremely expensive. And with those that are really expensive, it comes into play on different aspects of this cost of downtime. We have those things during an outage where revenue is being lost, employee productivity is low, and you're really losing out on that. And those get to do that cost that happens during an outage. After the outage happens, sometimes we do have SLA breaches that have happened. We have to give that money back to the customer. And when you're working in some regulated industries, sometimes this actually might include regulatory fines that you actually have to pay up. And sometimes we don't talk about this other aspect of the cost of downtime, the cost of our incidents, is that we have a lot of the unquantifiable part that goes into this cost. We have the brand information, thinking about the company industry being on the news, or a really bad outage that was on your high traffic event and people can't access a website, people can't purchase this item that they're really wanting. And not everyone has the cost of downtime, is not on everyone's top of mind, and we need to start changing that. We need to advocate for that being a more transparent conversation for engineers, understanding when they're contributing to the bigger cost of the organization, but to also think about reliability from the start a lot more. Just to touch base on the definition that I'm running with today for chaos engineering, is that chaos engineering is thoughtful planned experiments designed to reveal the weakness in our systems. The main part is that this is about revealing the weakness in our systems. It's not necessarily about breaking things on purpose, on production. You have to do this in a very thoughtful way. And some of the ways that we do that is there's a lot of guardrails, there's a lot of terminology that comes in play with chaos engineering. I'm going to skim through this really quick, but just to touch base on the terminology that will come up today as we go through today's session, we have experiments, which are the basis of chaos engineering. With experiments, we use a scientific method, so we always are going to talk about a hypothesis before running an experiment. We have two aspects that make up our safety mechanisms of where the chaos engineering experiment is going to target. That is blast radius and magnitude, and we have abort conditions. The way all of this comes together is right here on this slide. We start forming hypotheses as we observe our system. We look at what it looks like under normal conditions. We look at what those metrics, dashboards, log, any of our tooling says about the current state about our system. Then we can go ahead and form the hypothesis with abort conditions. If I inject a CPU increase into my systems, I believe my systems are going to stay up and running, but I also have to come up with abort conditions. What's going to cost for me to halt this experiment? And those are those abort conditions. Then we go ahead and define where we're running this experiment, that is the blast radius. We then define the impact of the experiment, that is our magnitude. That is when we say, I want this to be 50% of the CPU increase. Those things can be tailored depending on any experiment that you're running. You run that experiment, you analyze those results. If the experiment is successful, go ahead and expand the blast radius, expand the magnitude, and see how your experiment behaves. You're learning from the past experiment you've done, and you see for the next one. If an experiment is not successful, that's not failing. You learned something. Go ahead and make your system a little bit more resilient, change a few things, and run it again. When you now analyze those results, you're able to tell how your system is going to work, and whether it's a distributed system or just a containerized application, a bare metal application, how is it going to work and perform under these conditions that I'm giving it, whether the chaos engineering experiments or an increase in a state resource such as CPU, disk, IO, memory, whether you're cutting off a network access from the application, what happens if there's a latency increase into my database or the API that I'm using for all of our images or database. You go ahead and you always take your learnings from the first experiment, you make the second experiment larger, more resilient, and you run them again. You continue expanding the scope and retest. And my favorite part of the chaos engineering experiment flow is share results. We as an industry could continue learning from each other's failures. And that is one of the beautiful parts about chaos engineering. Go ahead and take those learnings, tell them to upper leadership what you're learning about injecting failure into your systems. But it doesn't just have to go there. You can go beyond that scope. You can go and give some talks at conferences about what you're learning about running this in your organization at scale or anything like it. It's part about experimentation and sharing that knowledge with the next person. I wanted to give a little bit of an introduction about me. My name's Ana Margarita Medina. I am a senior chaos engineer at Gremlin. I've been here for about 3 years. I've gotten a chance to be writing code since 2007. I've worked in front-end technologies, back-end technologies, research at universities, and have transitioned to work in site reliability engineering since 2016. I was lucky enough to join Uber and start focusing on the chaos engineering practice, which has allowed for me to find a niche topic and really become a subject matter expert and get a chance to evangelize to y'all about what learning from past failures and experimentation can do for your organization. Because representation really matters to me, I want to call out that I'm a Latina. I currently live in San Francisco, California, but I was born and raised in Costa Rica and my parents are Nicaragua. You can't be the job title that you want if you can't see it. So always like giving a shout out to any Latinx folk or underrepresented person on the call. To start talking about the topic that we're covering today, about the culture of chaos and failure, I want to kind of put up something out there. I strongly believe that humans are fallible. And this is that moment where I would say, raise your hand if you ever made a mistake. We're virtual, so can't necessarily do that. But I would like to launch a poll. Would you agree that humans are fallible?
Sorry, guys, my poll just froze on me, but let me go ahead and send it. All right. Okay, let's try it now. There we go. Yay, it worked. Sorry about that. All right, the poll question should be out on your screen now is, would you agree that humans are fallible? Select one of the following, yes or no. It's a pretty super easy question. So go ahead and make your choice. And for those of you who are still trying to decide whether humans are indeed fallible or not, just to let you know that we are going to have the webinar available as an on-demand following today's event in case you want to watch the webinar again or if you miss any or all of it. So, all right, I think it's pretty much an easy poll for folks to take. So I'm going to go ahead and close it out and we'll take a look at the results and then discuss accordingly. All right. Somebody out there thinks that humans are indeed fallible. And I can't imagine why, but okay. I don't even know what to say about this. Anna, what do you think?
No, this is perfect. It's always interesting because this question is always controversial. A lot of people are like straight up no. So to actually see 98% of you say yes, I'm really glad that all of you are here today at this talk.
All right, well, I'm going to go ahead and hide these results and I'll let you get back to it.
Perfect. So clearly the results were not what I was expecting, but for those, that 2% that said that they don't believe that humans are fallible, kind of go ahead and start with that definition of fallible. Fallible means capable of making mistakes, or being erroneous. So being able to cause errors, learn from them, and make it better. And that's going to be a portion of a lot of my talk. It's very much of it's okay to make mistakes. It's okay if our systems are going to break. Those are the breaking points where we learn, or we look at human aspects of things and you can learn about failures in your life that you've gotten up and tried a lot more. And that also just applies to just the engineering cultures that we're building in our organizations. And having a culture that allows for failure to be tolerable has led for more success for a lot of the tech giants. And one of the things that I'll continue iterating in today's talk is that we need to create a culture where we do accept all these mistakes and we accept that it's okay to fail, because failure is okay. Chaos is going to happen, and we should be seeking out failure just to learn. Those uncomfortable points is where we learn the most. Inclusive cultures embrace and inject failure, and you also go ahead and you celebrate it, because inclusive cultures create environments where failure is embraced, and we do understand that those humans are fallible. Things are not going to be perfect, and that is okay. We don't need to have engineers to be heroes. That's not the culture that we should push our technology industry to be, but just in general, chaos engineering doesn't want that. I mentioned that this talk will cover a little bit of what that culture is. One of the things that we did when we were writing this abstract for today's webinar is how is it that this culture piece ties into DevOps and SRE and chaos engineering. So for y'all, they're not very for y'all that are not understanding of what the SRE terminology is, or what this space is when is mostly DevOps technologies, the way that a lot of people at Google talk about site reliability engineering, because they are the ones that created this space and have built around a lot of resources for folks to continue learning about it, is that class SRE implements the interface of DevOps. In an object-oriented programming, a class is a type of an object. An interface is the set of actions that an object can do in order for that to be a class. It's very much of saying, if it looks like a duck and quacks like a duck, it must be a duck. This is very much of the way that you can look at site reliability engineering engaging with DevOps. When we try to answer the question of what is SRE, we have to go to Google to get this answer. And no, we don't mean go ahead and post on Google search, what is SRE? I mean, you can totally do that, but you'll find resources that Google has put out for this. You hear a lot from a lot of leads that have built site reliability engineering culture from the start at Google, from Liz Fong-Jones to Dave Renzen, and Google created SRE for that part, that you want to make sure you're reliable to your customers and you continue bringing up availability. So site reliability engineering is a practical implementation of DevOps with a goal of improving reliability. We start taking all the learnings and agileness and breaking down the silos that DevOps took us, but we do this in a way that we care about reliability. When we talk about site reliability engineering, there are various pillars that we talk about. There's various things that you need to work on, and we can see this in the pyramid that I have up on the slide. Over at the bottom of this pyramid, you see that you should start with focusing on monitoring and observability. If you don't know how your system is behaving, if you can't take a deep dive, whether it's observability or monitoring, you don't necessarily know how to make things better from there. You then have the aspect of incident response and post-incident analysis that come in play with that you kind of go really coupled together. And as you go up more, a lot of it is just caring about the reliability of every single one of these aspects: testing, release, and procedures, capacity planning, development, product. This is not an SRE talk. There's an entire Bible, the SRE Bible is what I like to call it, of what is SRE. There's a workbook around this, and there's a Seeking SRE book. There's a lot of resources to take a deep dive into that. But one of the things that comes with site reliability engineering is the aspect of practice. And if you're wondering what does practice have to do with this whole thing that I just explained called site reliability engineering, is that we can go back to this pyramid of things that Google tells us we need to be caring about in organizations to make things more reliable. When we go back to this, you can start looking at every single aspect of this and ask yourself, how is it that I make sure that my team knows these procedures? How is it that I make sure that I've put in enough time, money, and commitment to make these things better, more resilient, and just improve for the next person that I bring onto my team? I wrote them out for you. When we talk about site reliability engineering, sometimes it's very similar to those DevOps things where you hope you have implemented the right thing, but you don't always go ahead and you verify it. When we talk about chaos engineering, we can actually go ahead and look at the entire site reliability engineering stack and concepts and make sure that we're doing every single aspect of it. When I talk about monitoring and observability, you can go make sure that your dashboards and your runbooks and your links are all up to date. And then you can go ahead and you can also start by just setting up service level objectives, service level indicators. Where is it that I will find out that I am not meeting the request of my customer? What are those indicators and what are those objectives? When we talk about incident response, you have to train people on how to do a proper incident response. Specifically, we do this in a blameless way, which is the proper way to do things. And you can also go ahead and you make sure that the runbooks are not going to be 150 days old when your engineer gets paid for it. You make sure that all that has been updated. If you're a company that has many solutions for anything that has to do with service discovery, dashboards, monitoring, login, go ahead and make sure that you're actually updating the proper links in your runbooks to get to those references. And on that post-incident analysis, making sure that you know how to do the blameless postmortem write-up, that you're able to do that review, and I'll get a chance to talk about that a little bit later. Making sure that you have some testing release procedures, whether it's just the way that it's going to be set for every single one of your most important services, your step 0 services, making sure that amidst actually planning for how many servers and how many applications you need to have to be around for your high traffic events, you're also thinking about those failures and thinking about load testing and doing this in a harmony in a way. Then with development and product, you're going to ask yourself, how is it that I can set up error budgets that I'm allowed to fail and continue meeting the demands that I've promised to my customer? And just ask yourself, am I ready to launch this? Can I deliver my new product, my features, this new website to my customers reliably? And when I talk about practice, it just seems very, very heavy. But no, there's various different practices that you can do within chaos engineering that are very specific to the site reliability engineering pyramid. We have game days. Game days are a time to come together. You get a chance to share mental models of your systems. You start forming hypotheses over these architecture diagrams, and we ask questions. Then you get a chance to run these experiments. And I've sat in on a few game days where they've allocated 3 or 4 hours to do this, and the first 3 hours they're sharing mental models, they're talking about different things that they think would happen at scale if they were to run some chaos engineering experiments. and they only spent 30 minutes running one experiment, even though they had plans to run 3, because that whole process of getting to the experiment was them sharing what they think about their systems, how they behave, how they would scale, how the technologies that have been built for this are actually happening and talking to one another in the back. So it's not just about running the chaos engineering experiment, but it's all that process leading up to it. And the other concept in chaos engineering that helps you make all of this happen is fire drills. Fire drills are a planned time for your team to come together and run very much similar to the fire drills that we know in our day-to-day. How is it that we can make sure that our team is able to work together and get through these problems together? And this is very, very critical for going ahead and onboarding your engineers to on-call practices, making sure that you're updating those run books, running through past failures to make sure that your team has learned from it and they're able to maybe make that mean time to detection a lot less. Make sure that they're remediating those incidents in a quicker time, or just acknowledging that this is something that's still really hard, but you're making progress every single time you go, because you're just preparing them for the next page they get. Any single time, whether it's in a game day or a fire drill, they're just going to be a better engineer for that moment that is going to matter, that is going to happen, because failure is inevitable. And it goes back to some of those basics of chaos engineering, where we're going back to experimentation, but we're learning from it. We are going back to failure, but we're learning from it. We're seeing it from a lens where this is embraced, and we want to see this more in a way that is not customer impacting, but for the purpose of learning. I mentioned a little bit about blameless postmortems. This is a way that many folks have pushed the industry to do any of that post-incident analysis, of making sure that you're not putting the blame on folks. And it's a really, really cool space to get a chance to dive into, because a lot of regulated industries can't necessarily adopt this. So hearing the thoughts about this topic from those folks, or hearing it from the side of those engineers that have gotten fired or burned because they had been put to blame, but not the full story came out of that incident, and that kind of hurts. And I wanted to plug in that I'm not the person to be talking about blameless postmortems. And if you're actually wanting to learn more about postmortems, doing them blamelessly, in 2 weeks, 3 weeks, we're running a workshop. I'm running a workshop with PagerDuty on responding to chaos with PagerDuty and Gremlin, where we're gonna teach you everything about incidents and writing postmortems and doing this in a harmony with each other and learning from it. So feel free to go to gremlin.com/bootcamps to check it out. But I did take a slide on postmortems from this workshop, and this is PagerDuty's credit. This is everything about what makes a postmortem. The difference is that doing it in a blameless way is you're just not putting the blame on anyone or any team specifically. And this starts off by just giving a brief overview of what is it that happened, what was the impact. Then you actually write out a few more paragraphs of the events that have happened. You get a chance to reflect on what went well, what are some things that didn't go well and you want to continue improving on next time, and action items. Those action items are another part that you can later bring chaos engineering into, and it continues kind of making sure that the action items get taken, even if it's a month or 2 months out later. You want to touch base on everything that happened into your systems that contributed it to this incident, whether it was new deploys, new regulations of engineers having sudo access or anything like this. You get a chance to talk about what your team got a chance to do to actually resolve this incident. And when you talk about that impact, is very much of like, who did this affect? Was it just all of our internal customers? Was this customer facing? Did this just affect one customer? You want to go and also acknowledge any internal messaging that was brought up in this incident, whether you're telling your customers, whether you're telling another team, hey, can you explain to me what this rollout actually did on the back end? You also have that external messaging that's really important, whether it's on your status page, social media, emails to customers. And with postmortems, you always have to go ahead and have a detailed timeline of events. I know in incident response, there's a lot of companies that are coming up in this space because it's really complicated to do this. And when you talk to a lot of the people that are working at those companies, it's fascinating to hear about the large companies they've helped with incidents and being able to sit down with an engineer for 5 hours and then run through every single little detail of everything they did. And sometimes it's doing this in a very secluded way. You talk to one engineer at a time so that there's less bias and stuff like that, and you're able to really talk about the story and share about your experiences. Some of the benefits with postmortems and doing this in a blameless way too is that they can drive a culture of continuous improvement, and this kind of also ties into that embracing that your systems are going to fail. You get a chance to understand what are the factors that contributed to it. Then with the aspect of removing that blame is that you actually don't make people become victims, and you also get a chance to share more knowledge and people are less scared. And then you actually have psychological safety within your teams where they're trusting of each other. You are working as a team and not just one by one. The other part of chaos engineering that ties into culture is continuous validation. We want to create a culture of failure. We want to tell people that it's okay to fail. We want folks to inject failure on purpose, but how is it that you do this over and over and over again? Well, with chaos engineering automation, you're able to understand whether your team is ready to handle an incident, whether your team is able to be on call, whether the new grad that you're onboarding to your team has completed their course of being a secondary shadow and can actually also keep up to the standards that the team kind of has on resolving incidents and acknowledging pages. With chaos engineering automation, all that I'm talking about is implementing chaos engineering experiments in a continuous way in order for you to prevent regression into past failures. At the end of the day, chaos engineering automation is one of the things that you want to strive for, but you have to take baby steps to get there. And a lot of those baby steps are doing this manually for a while until you understand what your system can handle and you can be more thoughtful about the experiments you're unleashing. You also always want to start chaos engineering experiments in pre-prod environments, and when you've built that confidence, you go ahead and you automate it in your environments in production. So I mentioned earlier, you start small. You don't start by running chaos engineering experiments in production. That is the same way that you automate it. You go back to the starting ground of I automate the environments prior to production first, but that end goal is to automate on production. And when we're talking about doing this, there's various ways that you can do this. You can go ahead and schedule experiments. One of my biggest recommendations is to always schedule experiments within work hours. That way you can have the proper communication and make sure that people are not being paged at the middle of the night. There is a time to make sure that those middle of the night pages are also going in, but prior communications should be also provided, and also in the same aspect of fire drills. If you want to run that, you kind of want to have those conversations, already have a culture of psychological safety and embracing failure. And then you get the aspect that you can call in the API to do some of these calls in an automatic way with your GitHub actions, or you want to do this with any other type of automation that you have within your system. And with the same way with those API, you can just bring it into the CI/CD pipeline. That is one of those perfect points where every single time that you're constantly deploying, building more complexity to your application, you're releasing more code out to your customers, it allows for you to make sure that you're not regressing to past failures. So automation is that validation that your organization can really use to make sure that you're embracing failure, to make sure that you're friendly with failure, and that you're just taking the learnings from a single experiment a little further. When it comes to Gremlin products specifically, there's some other things that it offers in order for you to have automation. Some things are called status checks. They're basic guardrails that are health checks in order for your system to say, you can't run an experiment now. So an example would be, go and check if there's any incidents open on PagerDuty, and that's the status check prior to any experiment happening. And with that, you can also have one of those status checks be continuous. You can say, if my error budget for the month is being monitored by a monitoring company that gets reached, go ahead and stop that experiment. If it's a high traffic event and I have too much going on, go ahead and stop that experiment. You get to automate things with status checks by having those guardrails. Maybe it's making sure that your CPU never gets to 90%, because that's when things can maybe fall over, and your team knows that, and you're not that mature in your resiliency yet. You're starting to get there, but that's not the case. You can kind of use some of those things to help you validate and automate. Gremlin also has a community supported Python SDK that you get a chance to just bring that straight into your code. But a lot of this is just trying to figure out what is it that fits for your organization. Where does your organization go now, and what is the best way that you can kind of get them started with this embracing failure and doing this in a validation kind of way. And it's very much about understanding that we're building really complex systems. We're building maybe things that are very distributed, and there's going to be some things that we must test for, or we're going to suffer an outage. And sometimes these things can actually be found online. I recently gave another DevOps.com webinar on Kubernetes, and I talk about a website called k8s.af. That website is just failures that happen in Kubernetes. But when I talk about embracing failure, I also talk about you can learn from other folks' failure, and you can go read postmortems, you can go read any incidents that are happening to companies that you admire or that have similar products to you or are using the same technologies in the back end. What are the outages that they have suffered? What did they learn? How can I learn something from the investment that they made? And these are some things that you can then templatize and run those experiments constantly on your systems, whether it's GitHub outage from last year or the year before about data partition, whether it's AWS S3 buckets going down, whether it's making sure that you can do a region failover in a certain amount of time. Those are things that you learn from failure. It could be other people's failures, but nonetheless, things had to fail in order for things to get better and other people to learn. And this comes back to a lot of what the culture of chaos engineering is. You want to make sure that you're letting your engineers spend time building, creating value, and less time firefighting and managing risk. If you're constantly always in fear of not having a safe space to explore, learn, or even care about reliability, you should talk to your upper leadership. If you've done that, there's also times that you might need to start talking to your friends and see what their life is like and try to compare and contrast of what is it that you want to do. And you want to think about, how can I embrace the failures that we've had? How is it that I can go look at the incidents that I've had the last 3 months, at the incidents we've had the last year, and continue learning from them, and make sure that we've taken all the steps in those action items that we've outlined for us to continue building reliable experiences for our customers. Another topic that I put together to talk about today is people chaos engineering. It might be a weird concept for y'all, but it's been a topic that in the chaos engineering community, we've been talking about for a few years. People are part of this system. People are very complex. So let's go ahead and run chaos engineering experiments with them too. The two examples that I'm about to provide are not my own. I have to give credit to Dave Renzen, who does SRE at Google for them. He gave a talk at ChaosConf 2018 around this topic. But let's say you get an email at 9 a.m., but you can't respond before 10 a.m. We are now introducing a latency into a system. You can kind of see that there's a 1 hour delay from the person reading it to them responding. How is it that that's going to show up for the processes that you have in place? The way that Dave pitched this is that once a quarter, he was doing this where they selected 20% of the team, then at random, for that entire week, those humans were not able to respond to anything, work thing in less than an hour. Latency is the response that they were actually having. This allowed for them to start thinking of like, what are those hidden layers of dependency that we have in just person communication? We want to see what latency does to our people systems, our human factors aspect of our systems that we did not know existed. My other favorite example is that once a week, one person in your team sets out an out of office. That person is not available all day. They're not answering to anything. They have an unplanned office day for the rest of the day, just a PTO day. We are now replicating what happens if a critical portion of our system fails. If that person was to have an accident, take the day off, a medical emergency, that is exactly what we're replicating. We're allowed to this allows for us to now learn whether we have documented everything that person does that is critical to our day-to-day operations. Is it someone that had to build all the systems or keep everything in running? Is it someone that has a lot of knowledge of the organization that they haven't passed on over to someone? There's a term for this and I can't think about it for now. So all those things, how is it that you can learn about what's slowing your organization down? How is it that as a whole, you can all cohesively work together better and have latency and people failure in mind? Is kind of what these two come together. As I mentioned, go ahead and look for Dave Renzen's Chaos Engineering for People Systems talk. This was actually at ChaosConf 2019 that he gave it. You can type this on YouTube and you can find it. And you need to go ahead and accept that that failure happens. So you need to run chaos engineering experiments on everything from just the servers to your monitoring tools, any DevOps tooling that you have, your people, your managers, and allowing to understand how can y'all embrace failure and learn from it, but continue making your workplace better. I do work at a vendor, so I wanted to make sure to plug. If you're interested in talking more about chaos engineering, feel free to reach out to me or the team over at Gremlin. We have a platform that allows for folks to get started in just 5 minutes and run chaos engineering experiments across your stack. We offer a simple, safe, and secure way to do chaos engineering, and this allows for you to be thoughtful about your experiments. I mentioned some of the guardrails that you can think about with experiments and chaos engineering. Those kind of get built in product features. We have SOC 2 auditing. We are being used in some regulated industries like banks, and we have a pretty cool list of customers that include folks like JPMC. It includes folks like Twilio. And when you head on over to gremlin.com/customers, there's a better list because I can't remember it right now. I mentioned earlier that we have a workshop coming up that I'm very, very excited for. It is a 3-hour workshop that is super hands-on, and it allows for you to learn how to make postmortem writing easier, how to make sure that you can respond to failure any chaos in your system, working together in teams. So if you're interested, this is free, happening January 28th, 2021. And you can go over to gremlin.com/bootcamps to sign up. I hear there's a cool raffle happening at the end of that workshop. And I also would like to invite you all to join this greater chaos engineering community. We gotten a chance to grow it to over 6,500 folks across the world. Some of them have been running chaos engineering experiments in production for 4 to 5 years. Some people are just getting started in DevOps. And if you're looking to mentor folks, if you're looking to get mentoring yourself, go ahead and join this community and you might find some fun tidbits. I want to thank you all very much for your time. I would like to also offer some really cool chaos engineering community stickers. Every single year, I think I have a different favorite one. For the last 2 years has been the terminal with the spade, but I think I'm very much feeling the error this year of just like constantly thrown chaotic situations and trying to handle them and close them. So this sticker sheet, I love it very much. So feel free, if you're interested in getting one, head on over to gremlin.com/talk/devops-culture-chaos. With that, I would like to give a larger thank you all for those that have stayed through the end of today's workshop or are watching the recording at home. If you have any questions, feel free to reach out to me via email, social media. I've left my contact info on here, but we also have a bit of time today to tackle some of the questions y'all have. So feel free to start posting them on questions. I hope you all are staying safe and having a peaceful time amidst everything that's going on in today's world.
Awesome, Anna. Thank you very, very much. Lots and lots of good vibes happening here on this webinar. I love it. And you know what? I really like those stickers. I think those are pretty awesome. I like the one that says the tea. Everything is better with tea. It's kind of the universal mantra in my household is just have a cup of tea. It'll be much better. Anyway, yes, we are just about to dive into some of the questions that have come in, but there's plenty of time. If you have a question for Anna, please go ahead and use your GoToWebinar control panel, and we will try to get to as many as we can. But here's the first one for you. Okay, let's see. The word chaos scares my team. What can I do? It's so scary.
I hear this one sometimes, often. I think I know about it more than I actually hear it as a question. So thanks for anyone that asked it. Sometimes like what we've seen with our customers is that they need to rebrand it. They need to not call it chaos engineering. They need to just call it reliability testing. They need to call it the resilience program. There's different parts of, depending on the industry you work in, the organization's focus, the age of the company, and if you have adopted DevOps, if you've adopted SRE, depending on the length of those, sometimes it's easier. So feel free to rebrand it to anything that you want. At the end of the day, it's about injecting failure. It's about experimentation. And if you need to call it resiliency testing, that's okay. It's you understanding where your leadership is, understanding what your company is, and the chaos engineering community is still going to accept you. So feel free to come ahead and join us and tell us about that, where it's like your organization didn't feel comfortable with a certain term. So rebranding it.
All right, great. Next question here. How do I talk to senior leadership about making reliability a priority? I imagine you get this question a lot.
Yes, it's very much of people trying to understand, like, I continue pitching for my product to care about reliability, or my engineering team, and they just don't get it. And there's various things that you can kind of do. I think a lot of it, as I mentioned at the beginning, is, do they understand the cost of downtime? Bring it back to those numbers that the business really cares about. This is why you need to care about this. We're losing this amount of money. Like in the slide, it says that Amazon is expected to lose $300,000 per hour that they're down. That's on a non-high traffic event. Talk about what the last outage meant in revenue loss, or even just the full cost of downtime that those folks had. And if you're able to put numbers to this conversation, it definitely makes it like more apparent to leadership. sometimes it's a little bit hard to understand what the cost of downtime is going to be if you don't have those numbers, you have a hard product, or you have a small customer base. But a lot of it is very much of them trying to understand that if they care about this too late, it's going to damage the success of a company. And I think is that you can't be successful unless you embrace and you're friendly with failure. So how is it that you can present that for your leadership, for it to be accepted as we need this in order to be successful? And how is it that we can start dancing with failure? And a lot of it too is that you might see that some of the issues that you continue having end up being the same bug showing up different ways, of your systems not scaling as fast enough, or you start realizing that the proper communications are not happening within each team. Or I think the people chaos engineer experiments are also a really interesting way to talk about it. Like, if as a company we're not adopting reliability, if I do people chaos engineering, I don't need a tool, I don't need anything. You'll start seeing that this trickles down, and if you don't have that culture of failure, it's going to be hard.
Okay, all right, great. Still 5 more minutes or so for questions. So if you do have one for Anna, go ahead and use your GoToWebinar control panel and submit your question. All right, here's one. We are looking to move toward more of a DevOps/SRE model. So how can chaos engineering help?
Yes, so we have companies that have DevOps, we have companies that have SRE, and we have some that are still kind of hybrid, trying to figure out what they're gonna go with. And I kind of touched about it a few earlier slides with those pyramids, and it very much came down to you're implementing culture change, you're implementing these practices, new processes. Do you go ahead and you validate it anyhow? And how is it that you're making sure that all your company is up to speed? Sometimes in this digital transformations, sometimes communication is not happening, or many people have reserved thoughts around the new change, and you want to go ahead and continue breaking the silos. Like, I think that was one of my favorite things of the DevOps movement, continues being of making sure that communication is at the forefront and that people are talking to one another. So you get a chance to validate that, but you also get a chance to now practice everything that DevOps taught you, practice everything that site reliability engineering taught you, and continue making sure that you're implementing DevOps in the same way that you're implementing site reliability engineering, that you're always making reliability an important part of your structure.
Excellent. All right, great. All right, let's see. We got another question that just came in for you. Do you have any setup for I/O stress tests on object storage?
So we do have the maximizing the resource on the I/O layer, and it allows for you to also run it concurrently with a disk attack if that's something that you do. If you're looking at object storage specifically, I have no context of that. Like, my answer, I don't feel comfortable. But what I mean is that the way that Gremlin allows for you to do stuff is that we have a suite of 11 attacks, and because you're using one for a specific use case, you're actually able to bundle two together at the same time as two scenarios running. So if that's specifically what would help the object storage, like, that's something you can do. If it's actually just trying to understand what maximizing I/O would do to your system, you can do that. If you're trying to maximize I/O on a storage system, that's something that it can do as well. And you can have the very specifics. I think it's around like read-write bytes, the target that you kind of get to put in as a parameter. But yes, Gremlin allows for you to do things on the CPU layer, disk layer, I/O, memory. You then also get to shut down hosts, containers, you get to restart them, you can kill processes, you get a chance to shut them down. And on the latency layer, you get to black hole traffic, you get to inject latency, you get a chance to, I think those are the two that I remember right now, black hole latency, packet loss. You get a chance to test out packet loss. But head on over to gremlin.com and you can sign up for the Gremlin free account. and you actually get a chance to test the full suite of experiments onto Coast. So you can easily build object storage into a server and give it a chance. You can do things locally too.
Excellent, excellent. Okay, I think we have time for one more question here. How would you recommend getting started?
Hey, I just plugged it. Head on over to, you can go over to go.gremlin.com/Anna. You can use my link, and that gets you to the Gremlin free startup page. So you get a chance to just create an account with us, and this allows for you to have Gremlin free access forever. And with Gremlin free, as of like really recent, we have now ungated all of our attacks. Prior to that, with free, we only gave 3. You now get a chance to have 11. So if you're interested in getting started, I would say that just running your first experiment in a sandbox environment is the best way. The way that we talk about the hello world of chaos engineering, we either see it as what's known as a chaos monkey. What happens if I shut down my system? If I shut down my container, will like my application be affected? And I think parallel, the other one is the CPU attack. What happens to my system if CPU is spiked? Whether it's validating auto-scaling, making sure that your website is still up and running, all these little things can kind of happen, specifically when we have so many resources and applications that are running on our servers, that one bad memory leak, one bad object call, or a never-ending function is going to rack up your CPU.
All right, great. Well, that we're about 4 minutes to the top of the hour, so unfortunately that is all the time that we have for questions. If you do have a question for Anna, you can still go ahead and add it into the questions tab in the GoToWebinar control panel. I'll be keeping an eye on it in case we get any last minute questions. But for the most part, if we didn't get to your question, please know that the folks at Gremlin will be getting a copy of all the questions that came in. So you will get your question answered regardless, whether it's during the webinar or following the webinar. Also, a quick reminder to folks that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following the webinar today, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can go look for it there as well. Just go to devops.com/webinars, look in the on demand section, and it should be right there waiting for you. Okay, let's see. Before we close things out, I did mention at the top of the hour we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's do that before we close things out. Our first winner today is Joan A. Congratulations, Joan. Second winner today is Tori J. Congratulations, Tori. And our third winner today is David Yu. Congratulations, David. And our final winner today is Victoria J. Congratulations, Victoria. We'll be following up with all 4 of you offline via email to get your Amazon gift card over to you. So check your inbox. If you don't see it there, check your spam folder. Anna, thank you. Great presentation as always. As always, great to see you, and I hope we see you back soon.
Thank you for having me. Thank you all for watching. Stay safe.
All right. Also want to thank the audience for joining me today. And this is Charlene O'Hanlon, and I am now signing off. Have a great day, everybody, and stay safe.